Hello and welcome back to another ChronosHub webinar. My name is Anthony and I'm the head of product here at ChronosHub. And if you tuned in last time, we talked a lot about editorial operations and the author submission process, pain points, bottlenecks, etc. Two of the things that came up were around scope check and finding reviewers. So today we're going to talk about, the title is From Scope Check to the Right Reviewer, what semantic matching actually makes possible. And joining me here is a guest from the Netherlands, from Global Campus, Paul Tunenberg. So Paul, thank you so much for joining us and to discuss what your company is making and how maybe you have something that can help us solve some of the problems we talked about during our last webinar.
Yeah, thanks for the invitation, Anthony, and for the introduction. My name is Paul Tuinenberg, one of the founders of Global Campus, which is based in Utrecht, the Netherlands. It's a platform basically where we semantically match text to publication data. I will show and tell you a bit more about that platform in a bit. Basically, the whole premise of the platform is the question: how can we find academic expertise in a scientific world that not just specializes but also explodes in terms of content out there. And the traditional way of navigating through all of this data is based on keywords. Still, a lot of platforms rely on, let's say, a sophisticated version of matching with keywords. But we do this slightly different. Keywords don't really play a factor in us matching. Whenever we receive a text, we push this through a so-called transformer model. These are models we all know and use, I guess, almost on a daily basis, because these are like the backbones of the large language models. With a very important difference: we're not generating anything, right? So in the platform is no large language model that generates stuff. We just use the text interpretation part of this technology, and has a big advantage. With maybe not so scientific phrase, I look at cat pictures. These models understand that this means the same thing as me seeing feline photos, even though there's no overlap with any of the words. And it also does understand that I look at cat scans is something totally different, even though it shares almost every word of that sentence. And this is basically the backbone of what we do in Global Campus. So whenever people are searching for peer reviewers or searching for a journal to publish in, they give us a text, typically the title abstract, which is then matched against all the publications we have, and then we basically build this analysis of which of the publications are similar, and then just to conclude that the authors of those publications must be a good expert on that field, and the journals where these are published in must be a good fit for you to publish in as well. And in a simplified version that looks more or less like this, here we see an image with 3 dimensions. These models work with almost 400 dimensions, so it's a bit bigger and harder to draw than what we see here. And in our search cluster, all these dots represent a publication, and whenever we receive a text, we plot it in this same space, and then check which of the publications are close by, and therefore those must have a similar meaning. So that's how we do the matching. And the data we use, that's also a very important part, of course, is totally open. So it comes from OpenAlex. For those of you who haven't heard of OpenAlex, it's a non-profit that basically is building the largest repository of metadata of academic content. So it has over 450 million academic works. So as you can see on the image on the right, it's quite a bit larger than Scopus and Web of Science. It has a much better coverage of the Global South, which is especially in the peer review use case useful. to also find people outside the obvious institutions that you can invite to be a peer reviewer. And the nice thing about open data and open source is that it's totally transparent for everyone to see what is in the data, what isn't there, what are the mistakes, and also when someone requests improvements for maybe wrong affiliation data, it benefits the entire academic institution, academic landscape, and not just us or not just the party that is improving the data. And an increasing amount of parties are using this data, so there are also more people that share feedback to improve. All right, so that's like a short introduction on how we do the matching and what data we use. There are a few use cases of which we will highlight on the journals. So Global Campus is used to find peer reviewers, usually in an integration with the submission system the publisher is using. And there are also a couple of organizations using it to assign editors and then also balance the workload of these editors. And this is especially relevant for those journals where there are like that many editors that it's a bit hard to manually assign those people to the right manuscript. And that's something then where a Global Campus gives a suggestion. But the first use case, the one we will focus on today, is basically to identify journals to publish in. And then again, within this use case, there are a couple of routes to use it. So one way would be within the universities or the libraries, where it serves as a platform or tool for researchers to select any journal they could publish in based on what this journal previously published. And on the side of the publishers, there are a few points in the workflow where this could be beneficial. Some large publishers just have an open journal search on their website where you enter a text or some keywords, but in our case that would be the abstract of your manuscript, and then it will show which of the journals in their portfolio would fit best. But you could also think about an implementation where it's part of the submission flow and that it helps an author to select the best fitting paper, or maybe suggest a different journal if they select journal A where journal B would be a better fit. And thirdly, it could also help editors to give alternative journal options to authors that they prefer to let publish somewhere else. So how does it look in our interface? There's like a whole range of filters you can apply, but the basics are pretty simple. We start with the text, as mentioned, typically the title and abstract. We match it against publications, and then we check where those publications were published. And then we just show the titles and the publisher in an interface. And there's a whole range of filters you can apply, both on the level of the works, where we do the matching. So how far back in time do we want to match with publications? Maybe apply some specific filters on those publications. For instance, that should be within a specific academic discipline. A whole range of filters on the sources. So maybe you only want to match against journals of a specific publisher, or maybe exclude a specific publisher. And all sorts of filters about whether the title is open access or not, or listed in specific repositories. So the way it would serve as a scope fit check would typically be through our API, where our interface is actually not really used, but just the matchmaking is used. So here you see two screenshots, one where we only show Taylor and Francis results, and one where we only show Wiley results based on the same query. And that's basically also how it would serve in a scope fit check, where we will receive the title and abstract, match it against the publications of a given publisher, and then rank the order of which journals would then be the best fit. And this is only based on the semantic overlap between the already published works in that journal with your manuscript text. And we've done some pilots with this, which I will show you right now. So what we did earlier this year is we received 1,000 published articles that were published in 26. Then we semantically matched against the publication between 2018 and 2025. And then checked together with this publisher, like how often did we find the journal where it in the end was also published. Knowing, of course, that just the semantic match is not the only thing that is part of the equation of selecting a journal, of course. And there we saw that in 37% of the cases, the journal where it was published was also our top one recommendation. But what we told them is that it actually makes more sense to look at the top 5 or even a top 10. And in the top 5, we saw that in 74% of the cases, the right journal, so to say, was included in the top 5. And when we took a look at the top 10, it was even around 90% of the cases where the right journal was included.
And Paul,
sorry, yeah.
Yeah, we have a few questions, and I was wondering, do you want to take them now? I think they're sort of relevant to this section.
Sure. Yeah. Please go ahead.
Yeah. So the first question was, if I write my manuscript in my own language, will the tool still find the right English journals, or do I need to translate first?
Currently, you would need to translate. We made the decision to use English to English matchmaking algorithms because they basically, for 2 reasons, they perform a bit better when you have English text, and the vast majority of publications is in English. However, we did some experiments with multilingual matchmaking algorithms, and they work pretty well, but just a bit less than the English to English ones. So it's possible, but currently you would need to translate.
Okay, thanks. And then the second question was, what about newer, smaller journals? Do they show up in the results, or does the tool mostly point me to the big ones? And I guess that's sort of another, I would also add maybe, how do you view your tool in the context of a dependency on OpenAlex? And, are you looking at other data sources, et cetera?
Yeah, so if you use this in the context of one particular publisher, you could also link it, of course, to the data of that publisher. And let's say to go to the source, right? And use the data that they rely on as well. In terms of like the smaller, newer journals, will be, in a way, will have a penalty because they have published less. And we also saw in the data that the very broad scope journals, they're almost always in the top 10. And if I'm not mistaken, they were always in the top 10. But they never ended in the top 1 because they are that broad, right? So they publish a lot. So there's always some semantic overlap. But there's almost always a better fit if you really zoom into like what is this text about. Then in most cases there is like a more specific journal that is a better fit than the general one.
Okay.
So and this is something that you can play with a bit, right? Something you can tweak. So we did a few rounds, and the numbers I'm showing here is where we gave a small penalty to this very large journals, where we would sort of relate the matching scores to the size of the journal, which was like in favor of the small journals.
Yeah. And one last one here. Do you also consider novelty or significance of the research in addition to the usual scope parameters, or is it basically that's a maybe separate?
Yeah,
you
that
know,
will actually be
broaden.
on one of the next slides. That's actually a
Okay.
potential avenue
All right,
to.
we got ahead of ourselves in the questions, so
Yeah,
yeah, I'll let you continue.
that's good. Yeah, so this is really just based on what this journal historically published. So if there's like an editorial decision to focus on a slightly different subdiscipline, um, we will need some adjustment time, so to say, to recommend the correct manuscripts for that journal, because when matching it based on historically publications, it's always a bit looking in the rear back mirror to make a prediction of what would be a good future fit. And we also realized this, right, that just the semantic overlap with previously published content is not the only way of making a decision. So this is where your suggestion or question comes into the equation, right? There are all sorts of things that could also play a role, whether you want to focus your journal on like radically new ideas or incrementally new ideas. And maybe there's like transformative agreements between your institution or maybe even your country and the publisher, how broad or narrow scope the journal is, the APCs involved. So there are all sorts of other things that could influence a decision that is not part of this the scope that we currently do. Currently is really just based on the similarity and meaning of your manuscript and the similarity of the published materials in that specific title. And that's definitely, there's the potential to improve, right? And I'm not sure if this is something that would come from us or something that we better do in a partnership with the publisher themselves, because they have a lot of information, of course, about these journals that could make these scores better. And I guess this also depends on how you want to use it, right? How what is the aim of this scope fit? Is it like a nice suggestion to authors to say like, hey, have you considered these other titles that could also be a good fit? Or is the aim to have like the perfect prediction model to say like to maybe almost guarantee that someone will get published if they choose the recommended journal, which is obviously much harder than giving a list of options.
Yep, thank you.
I'm not sure if there are more questions, because with this improvement slides, we're actually getting to the end of what I wanted to show.
I mean, the improvements, there is a question related to improvements, I think, which is how often does the model get retrained? So I guess things are changing every day. How do we ensure that there's always looking at the latest information?
Yes, so we keep track of the quality of our models by checking it against systematic literature review sets. So these are sets where the authors included the 15,000 publications that they included for the analysis, and they also flagged which, let's say 20, they included in their review. And then we check for the quality of the models by giving it 1 out of these 20, and then see how quickly it will find the other 19 out of the 15,000. And this is something we regularly check with different models, different embeddings. And that's how we ensure the quality of the matching. But it's not like we need to retrain these models every week or every month. That's not really, well, let's put it differently. That's not adding any quality to the matches.
Right. And then what if a paper just sort of is like a split between like two different types of topics? Or I guess I think we talked about like what if the journal was broad, but like what if the article itself or the manuscript has sort of like a push and pull in two directions?
Yeah, so this is indeed tricky for these models. We see it the same when searching for peer reviewers, that when something is really in between two disciplines, that the embedding, the thing we compare, is some sort of average of these different types of texts. So currently there are filters you can apply as a user to say like, okay, I only want to include papers that were tagged as being part of a specific discipline, and or only include papers that make use of specific keywords to make sure that you're really in the, I don't know, biology part of that subdiscipline instead of the chemistry part of that discipline. And we're also working on, well, we have an implementation, but working on a better version of a technology called active learning, where you basically feed the matchmaking algorithms with the examples that you think are the right ones, the good ones. And that will sort of live train or tell the algorithm which, I don't know, rabbit hole within the discipline it should dive into. And that's not stored for future users. It's only for that one specific search. But that would then be the avenue to support you as a user in finding these difficult cases where there's like a mixture of 2 or 3 disciplines.
Yeah, and could you talk a little bit about maybe the implementation of some of this in sort of a real test case? So, for example, like general author tool to find like a journal, just out in the wide world, or like a specific implementation for a publisher where once you're submitting to a journal within a publisher, maybe there's some kind of check to make sure like, hey, like you're actually publishing to the right journal. So maybe the question is, what does it look like in the wild?
Yeah, so there are a few people having access within their university to like the web-based version of Global Campus, where they just log in, enter their manuscript text, and apply the filters they think are relevant to identify a journal in the world that would be a good fit. But currently we're actually more focusing on the publisher use cases, where there are actually these 3 routes I mentioned before. So one is like a general journal search, like I know at least Elsevier has on their website, but I believe also Sage and a few others, where as I don't know, an interested a person who's interested in that publisher can just do a brief check on their website to see how well or if there are any journals that would fit well with your research ideas. And the most promising, I guess, implementations will be the author facing when they are in the submission flow, when there's basically some sort of check while doing the submission to see whether there are not any better journal fits within that publisher. That would maybe increase the chances of publishing, because the alignment in terms of the content is better with another journal than with the one you selected. And the third one would be the same, but then for the editors, that if they are in doubt about how well the fit of a specific manuscript is with their journal, to actually have an option for this author to say like, well, maybe it's not the best fit for this journal that you selected, but we have a few options for you. And based on the conversations we've had, this could be quite a time intense thing to do for editors to, well, either you're basically just telling like, well, this is not a good fit, good luck. But if you want to do a bit more and maybe keep those authors for your, for one of your titles, then it's nice to be able to give some recommendations. And that would, then be where the global campus matching would play a role.
All right, perfect. I don't think we have any more questions. Going once, going twice for the folks on the queue here. a second. All right. Well, there's no more questions. We can wrap it up there. Paul, thank you so much for joining us, and thanks for everyone for attending. And I hope you found this useful. And if you want to find out more about ChronosHub, you can check out our website, chronoshub.io. And Paul, where can they find you?
Campus, globalcampus.ai.
Globalcampus.ai. There are too many of the endings now to keep track of. But thank you so
Yeah.
much for joining, and we'll see you soon. Thank you.
Thank you.